Now let's talk about proportions and the properties of proportions. A proportion is an equation stating that two ratios are equal. And in all proportions, you have extremes and means. Extremes are the first and last numbers in a proportion when it's written using colons. And the means are the middle two numbers when it's written using colons. Now, if it's written using the vinculum as fractions, it looks more like this. The extremes are the upper left and lower right, and the means are the lower left and upper right. Now you probably all remember the cross products property of proportions. This simply says that if you multiply the means and you multiply the extremes, those products are equal. In other words, if A over B is equal to C over D, then AD is equal to BC. We use this most frequently to solve proportions. So we can solve a couple of proportions here really quick. This first one, we'll use the cross product property of proportions. So that tells us that 8x is equal to 66. We'll use the division property of equality, and then we will simply simplify the ratio that we got. So x is equal to 33/4. Leave your answers as fractions. Do not put them in mixed numbers. Do not change them to decimals. Now for this next one, it's a little trickier. We are going to use the cross products property of proportions, but notice when we multiply the extremes, we get y times the quantity y plus 6. So we need to distribute the y to everything inside the parentheses. Y times y is y squared, and y times 6 is 6y, and of course 8 times 9 is 72. In this situation, we're going to need to use the subtraction property of equality to make the equation equal 0. To solve a problem like this, the equation must equal 0. And now we have to do factoring. I hope you remember this. If not, use some online resources to brush up your skills. Y squared plus 6y minus 72 factors into y minus 6 times y plus 12. We're going to separate this into two equations, y minus 6 equals 0, or y plus 12 equals 0. And then using the addition and subtraction properties of equality, we realize that y is either 6 or negative 12. Now there are other properties of proportions that are very important. The first one is the reciprocal property of proportions. This one says that if you reciprocate one ratio, you can reciprocate the other, and you'll still have a true statement. So if A over B is equal to C over D, then B over A is equal to D over C. We also have the means exchange property of proportions. This says that if you exchange the means of the two ratios, the proportion will still be true. In other words, if A over B is equal to C over D, then A over C is equal to B over D. Notice we've just exchanged C and B. And our final property of proportions I like to call the numerator-denominator sum property of proportions. And this says that you can add the denominator of each ratio to the corresponding numerator and still have a true proportion. It sounds crazy, but what that means is this. If A over B is equal to C over D, then A plus B over B is equal to C plus D over D. In our numerators, we've just added the two denominators. Okay, so now let's kind of use this really quick. Let's write an equivalent proportion. So we're given that x over 8 is equal to y over 9. What ratio completes the equivalent proportion x over y is equal to some other ratio? Let's blow this up and take a look at it. Now, what I'm looking at here is I'm noticing that the y has moved from the upper right to the lower left. And now it's overlapping that 8. That's ugly. So I'm just going to move the 8 out of the way for now. Oh, wait. What did we just do? Didn't we just exchange the means? That's the means exchange property of proportions, which tells us that the ratio that completes the proportion is this 8/9. And we're done. So that's how we can use these properties of proportions to both solve proportions and write equivalent proportions.